building, and this is analyzing that I want to write. Building and analyzing a function graphically. All this long grammar, all it means is we are just going to use graph to build a function or to analyze already created function. That's all it means. So now what that means is you may be given a table to plot a graph, or a graph may be plotted for you, and based on the graph that is plotted, you'll be asked to create a mathematical model for it. So now, because we are trying to build a function, so we may be given a hint of how the function looks like with a table. For example, I can create a table that looks like this. So draw with me, work with me. So this is a table that I'm creating, and then I will write the x values and then write the y, the function of x, which is y equal to k x raised to power n. Then I may put numbers for x to be something like 2, 4, 6, 8, 10, 12, and so on. And then the goal is to complete the table. And you see, k is a constant and n is a number. N is a number. So now, given that k, which is the constant of proportionality, is equal to, given that k is equal to, let's just give it a number. Let's just say it is 1/2, 1/2. Given that k is 1/2, and n equal to 2, and n equal to 2. So the first question is complete the table. Then after completing the table, then plot the graph. Okay? So now let's pick one of the numbers here. Let's pick one of the numbers here to complete the table. Let's pick one of the numbers. So which one do you want? Do you want 2, 4, 6, 8, or which one do you want? Just pick any of them. When x is equal,
8.
Okay, let's do when x is equal to 6.
Yeah.
All right, let's do when x is equal to 6. So all you need to do is you write your y and is equal to, they said k is 1/2. So 1/2 multiplied by, and then x is 6. So you write your 6. No. Yeah, x is 6, and then n is 2. They said that n is 2. This is supposed to be 2 when n is 2. So x raised to power 6 raised to power what? 6 raised to power 2. So once you have this type of thing to evaluate, you have two options. One is to use your PEMDAS, the other is to punch in the number into your calculator. So let's say we're using PEMDAS. So that's going to be exponent first. So you have 6 raised to power 2 is 36. So that is going to give you 1/2 multiplied by 36. And what should that be?
18.
18. So here is 18. And then you use that same method, the very same method, you use that to compute for the value when x is 2, 4, 8, 10, 12. After you
Mr.
yes.
In the function, does it say y equals kx?
Yeah, kx raised to power n. Kx raised to power n. The x is raised to power n, not just x. Okay? It is x raised to power n. So the function is y equal to kx raised to power n. That's the function that is given. So once you are done with completing your table, the next thing you do is you create a scale for your graph and then you plot it. So you are going to plot something that looks like this. This is your y-axis. This is your x-axis. You look at your smallest value of x. So that is going to give you 2, 4, 6, 8, 10, 12. And then this one is already 18. So you may use something like 5, 10, 15, 20, 25, or you can use 10, 20, 30, 40, 50. So you select your scale based on your minimum and the maximum. So you make sure that your maximum is accommodated in your scale. So this is y-axis, and then this is the x-axis right here. This is the x-axis. So this is 2, 4, 6, 8, 10, and then you keep going. It might even be negative. It might even have negative values. It might also have negative values. So it just depends on whatever you are given. So after doing that, then you plot your graph. So once you plot your graph, the graph will show you whether it is a straight line or whether it's a curve. If it is a straight line, is it a direct variation or an inverse variation? That's what the graph is supposed to tell you. So in this case, when x is 6, y is 18. When x is 6, 6 is somewhere here, y is 18. Okay, so let's do one more value for x so that we can have at least 2 values. Pick one more value of x. Spread it apart a little bit. Either you pick 2 or you pick something like 10 or 12.
Mr. I have another question.
Yeah, hold on. Let's plot this one. Then you bring your question, unless it is related to. Well, go ahead with your question anyway. Go.
What was the first point that you plotted? I can't really see.
Okay. The first values that we are given is 2, 4, 6, 8, 10, 12. Now on my scale, we just decided to get the value when x. Now I'm asking you to, let's do another point, either when x is 2 or when x is 10. It doesn't really matter to me. What matters to me is that you make sure that you understand how it is done. So
Mr.
pick another point. What?
I think you put your plot in the wrong place. It's 18 and you put it under 10.
Oh, sorry. Yeah, that was my mistake. Thank you. At least somebody is paying attention. Thank you. I like that. So it should be 6 and 18. 18 should be somewhere here. Right. Thank you. Next point. Which one do you want us to do? Hurry up, please.
12.
12. Okay. So if it is 12, you do the same thing. Y is going to be
1/2.
y is going to be 1/2 multiplied by
12 to the second power.
12 to the second power. Thank you. And 12 to the second power is 1/2 times 144. What does it give us? 72.
Yes, 72.
So it should be 72. So this is 60, this is 70, 72 is somewhere here. So, and then of course, you know, you have to expand your point. So 72 is somewhere here. Okay, so you can see that it looks like a straight line. All right, and if it's a straight line, that's a direct variation right there. If it's not every straight line is a direct variation. If it's a straight line and going from left to right, increasing from left to right, that's a direct variation.
Can you repeat that again, please?
I said if it is a straight line and it is moving, increasing from left to right, then that's a direct variation. Another way of saying it is if the slope is positive, then that's a direct variation. If the slope is negative, then that's an inverse variation. Let me write it again. Let me write it in this way. Let me give you a general sketch. This one is direct variation, and if the scale goes like this, so this is inverse right here, inverse variation, while this one is direct variation. You can see this one as x increases, y decreases. 1, 2, 3, 2, 4, 6, y, x here. This is x, and then this one is y. So this is one way to identify it. You see, in this particular case, as x is increasing, y is also increasing. So this one is direct variation. Okay, so now what I'm going to do right now is, so you may be given a set of points to plot, and from that set of points, you will be expected to identify whether the graph you plotted is a direct variation or inverse variation or any other type of variation. Okay.
Okay.
So that's what we are going to.
Excuse me, I have a question.
Yes, go ahead.
So for the inverse variation, is the slope negative?
Yes, yes. Slope is negative. Once you calculate your slope and your slope is accurate, then if it gives you a negative number, then that's an inverse variation right there. But you have to, if you're doing calculation, you have to make sure that your calculation is correct. You have to make sure that you're applying your formula correctly. For example, m equal to y2 minus y1 over x2 minus x1. If you apply it correctly, then if it gives you a negative slope, then you have an inverse variation. If it gives you a positive slope, then you have a direct variation. All right?
Mr. Okebu,
Yes.
can you explain combined variation and joint variation again?
Yes, yes. A combined variation is a variation that combines both direct and indirect variation, both direct and inverse variation. For example, I can say the function y. Okay, let me use another one. Sorry, the function z varies directly as x and varies inversely as y. That this kind of statement. So this is a combined variation right here. What that means is z varies directly as x and z varies inversely as y. So now when you combine the two, you are going to have that z varies as x over y. So now if you remove this sign of proportionality.
What's that sign between z and?
So if you remove this sign of proportionality, you are going to have.
Okay.
Yes, thank you. Yes, it should be z. It should be z. Thank you.
What's the sign right there between x and z?
It's called it's a Greek alphabet, and that's what you use in identifying variation. So it should be z. Z varies as x and inversely as y. So when you remove this sign of proportionality, you can write z is equal to k x over y. So this becomes your equation. And this is combined variation. So this is combined variation. Now, on the other hand, if I use the same set of variables and put my question this way, if z varies directly as x and y, so that means z is proportional to x and also proportional to y, and that means z is equal to kxy. This one is joint variation. So in both cases, they are going to give you the initial value for x, initial value for z, initial value for x, and initial value for y. That's what you are going to use in determining the value of k. Once you determine the value of k, they can now twist the question in different ways in order to either find z or x or y. Does that make more sense now?
Yeah.
Okay.